Hello everyone, I am Mansi Mahindru from ABES Engineering College, Ghaziabad. In today's video, we're going to discuss about divide and conquer technique. And in this session, we're going to start with a very famous example of divide and conquer technique, that is matrix multiplication, or in this subject, we used to call it as Stressen's matrix multiplication and convex hull problem. So now let's start with the session. And first, we're going to start with matrix multiplication. Okay, so first of all, let's understand what are our main agendas of this topic. So firstly, we're going to discuss about how matrix multiplication is done normally. Like in our BTech first year, when we started with our computer programming, and the first program that we have written is addition of two numbers or multiplication. So when we have written the algorithm for multiplication of two numbers or multiplication of two matrices, at that time we know that we used to have three for loops in our algorithms. Likewise, we'll discuss that also in this video. And after that, we're going to start how divide and conquer strategy helps us to improve the time complexity, or is it really help us to solve the time complexity problem or not. And at last, we're going to start with what are the advantages of using Stressen's matrix multiplication over normal multiplication or divide and conquer technique. So these are our main agendas of this topic. So now let me take my pen. So first of all, when we started with our multiplication, we used to multiply two matrices, such as if we have two matrices A and B. And if we'll multiply these two matrices, we'll get the resultant matrix as C. Okay. And if we'll write the algorithm for the normal multiplication, we'll write it like this. And clearly, if we'll do the analysis, we can see that we are using three for loops. So its time complexity will definitely go to O of n cube. After that, after this normal multiplication, we came up with divide and conquer strategy. And in divide and conquer strategy, it says that if we're going to divide our big problem into number of sub problems, and then after that it will solve each sub problem recursively one by one, then it will help us to reduce the time complexity. Now, what is the main agenda, or what is the main objective? How it actually works is, if we have two matrices, A and B, and the dimension of these two matrices is 2 cross 2, and then obviously the resultant matrix that we're going to get will be also 2 cross 2 matrix. So these are the formulas which we can use to multiply these two matrices together. Like for example, if I want to find this value, then I have to multiply A11 into B11 plus A12 into B21. Likewise, we are going to calculate C11, then C12, C21 and C22. Now, this is the calculation that we're going to do if our matrix is of the order 2 cross 2. Now, what if our matrix is of order 4 cross 4, is of order 8 cross 8, and so on so forth? So, divide and conquer strategy says that whatever is the dimension of our matrix, we will going to divide that matrix in 2 cross 2. That is the smallest problem we can tackle for the first time. So you can say, it says that if the row and column size is greater than 2, then we need to divide our problem in the sub problem, and we have to solve each sub problem recursively. And we take the problem or assume the problem of power of 2. Like, for example, if we have matrix of the order 2 cross 2, then we can say that it at this point of time we have matrix 2 raised to the power 0, right? sorry, 2 raised to the power 1. Now, if we have matrix of the order 4 cross 4, it means we are talking about the matrix 2 by 2 raised to the power 2. Okay. So it means if we want to apply divide and conquer strategy on our matrices, then matrix should be of the order 2 raised to the power n. But if the matrix is not the power of 2, then we will make it by adding extra zeros wherever required. For example, if matrix is of the order 3 cross 3 and we can only apply divide and conquer in at 2 cross 2 matrices or 2 raised to the power n matrices, then at some one row will going to insert all zeros. That will help us and it will convert that matrix to 4 cross 4 matrix. So this is the main idea behind this particular technique. Now, as you can see here, what we are doing, see, this is our first matrix A, this is our second matrix B. Now, this matrix is of the order 4 cross 4. This is of 4 cross 4. This is of 4 cross 4. And divide and conquer strategy only works on 2 cross 2 matrix. Means a base condition, the smallest condition is that matrix should be of the order 2 cross 2. And if the matrix is of the order 4 cross 4, then please convert it in the order 2 cross 2. So how we're going to divide? See, we are dividing it like this. Yes. We are dividing. We are dividing our 4 cross 4 matrix to 2 cross 2 matrix. And now this will become A11, this will become A12, this will become B11, and this will become B12. This is our A21, A22, B21, B22. Now similarly, our C matrix will also be of the order 4 cross 4. So we'll divide it again in 2 cross 2 matrix. So it will be C11, C12, C13, C14, and like we have 4 cross 4. So what we will do, we will have this as A11, A12. Sorry, this should not be A11, this should be C11, C12, this should be C21, and this should be C2, C22. So this is our matrix now. Now, how we're going to apply divided conquer strategy in 4 cross 4 matrix? See, this is the algorithm that we can use. As you can see here, it is clearly written that if the dimension of the matrix is less than or equals to 2, then you can directly compute it with the help of formulas. But if the order of the matrix is 4 cross 4, 8 cross 8, 16 cross 16, and so on so forth, then what we need to do, we need to divide that particular matrix in the order n by 2, like we have done in the previous slide, and we have to define it recursively. So as you can see here, if I need to calculate the value of C11, see, C11 is nothing. It is A11, capital A, A11 into B11 plus A12 into B21. So we're going to apply the same formula here. As you can see here, we're going to multiply A11 into B11 plus A12 into B21. And recursively, we're going to divide our matrix in, will reduce the size of the matrix so that, see, for the very first time, when we're going to divide this 4 cross 4 matrix, we're going to get 2 cross 2 matrix. And when we'll enter in this loop, this condition is true, then we can simply apply our formula and we can calculate the value. If our matrix is of the order 8 cross 8, then we have to run this particular else part 2 times. And again, after that, we can simply compute the values with the help of these formulas. But now, our main thing, the main purpose of doing so many computations is that is our complexity is reduced or not. That we have to see. So let's understand what is the time complexity in doing all these tasks. So let's understand. See, as you can see here, this is the time complexity analysis of divide and conquer strategy to multiply two matrices together. See. So it is saying that if the dimension of matrix is less than or equals to 2, then you can simply compute it with the help of formula. So it will take O of 1 time. But if the dimension is greater than 2, then we have to, the time, or you can say the recursive equation is 8n by 2 plus n square. How is it? See, the total multiplication, see the else part, just check the else part only. The total multiplication we are doing is 1. See, let me take different pen so that it will be easy for you to understand this. First of all, we have to count how many multiplication we are doing. So this is the first time we are doing multiplication. This is for the second time we are doing 3, 4, 5, 6, 7, and this is 8. So it means the total multiplication that we're going to do is 80, right? And every time we are dividing our problem, like we are dividing it to half. So as you can see here, na, we are dividing it to half. So it will be 80 n by 2 plus. Now the total additions we are doing is 1, 2, 3, and 4. Now, whatever number of times we are doing addition of the two numbers, it will going to take O of n square. So its recurrence equation is 80n by 2 plus n square. And if we're going to solve this particular recurrence equation using master method or using recurrence tree, using iteration method, we're going to get O of n cube. You can go, you can pause the video and you can check it. So, but what's the benefit of doing all these computation? Because with the normal multiplication also, we are getting the same time complexity, O of n cube. And after doing so much computation, by applying recursion, by which we are also increasing its space complexity, we are not getting any benefit because this from this method also we are getting same time complexity. So now here comes Stressen's matrix multiplication. So Stressen says, I will going to help you to reduce some time complexity. It says, as you can see here, let me take my pen. Yeah. It will going to reduce total number of multiplication from 8 to 7. Means in our previous recurrence equation, see our previous recurrence equation is 8t n by 2 plus O of n square. So it says that I will reduce this 8 to 7. Now we'll see how it will do. And it says different formulas are applied in the four equations. Means in the previous video or in the previous approach, we are using these formulas, or we can say the basic multiplication formula that we are studying from our first year. Basic formula we are using. But here we're going to use different formulas in the four equations, and number of multiplication is reduced, but additions and subtractions is increased. So with the Stressen's matrix multiplication, because as we have seen in the previous approach, we are only doing addition for 4 times, but it says that as compared to multiplication, addition and subtraction will get increased. So this is the main idea behind Stressen's matrix multiplication. So these are the formulas that we have to use And in your university exams also, na, you will going to get simple question of 2 cross 2 matrix only. They'll not going to give you 4 cross 4 matrix for sure. They'll not going to give you that. They'll give you simple 2 cross 2 matrix question. They'll provide you two matrix A and B, and you have to apply Stressen's matrix multiplication. So what you can do is you have to apply these simple formulas which are given on your screen. You can just pause this video and you can note down these formulas, because these will help you to solve all the numericals. So first of all, what we need to do, 1 minute, let me take a different pen. Yeah. So first of all, we have to find out the value of P, Q, R, S, T, U, and V. Right. So first you have to calculate the value of P, Q, R, S, T, U, V, and after that, by computing these PQRSTUV, you have to apply these values in these four equations. Like in previous video, or sorry, in the previous slide, a previous approach, C11 is nothing. It's A11 into A12 plus A21 into B21. Yes, but here C11 is equals to P plus S minus T plus V. C12 is R plus T. C21 is Q plus S. And C22 is P plus R minus Q plus U. So this is basic formulas that you have to apply in order to solve question from Stressen's matrix multiplication. Now, our main point is whether our time complexity gets reduced or not. That we have to check. So, the total multiplication that we are doing in this particular approach is, let's check out. First time we are doing multiplication here. Second time we are doing it here. Third, fourth, fifth, and 1 second. Sixth time we are doing it here. Oh, I'm so sorry. It should be 70. It should be 70. It is not like this. 3, 4, 5. 1 second. It is 1 minute. Let me complete it. Yeah. So we are counting number of additions. 1 second. Yeah. It should be A11. Just correct this formula. It should be A11. So then this is our seventh time we are doing multiplication. So our equation will be T of n is equals to 7t n by 2 and plus. Now we're going to calculate and we're going to count how many times we are doing addition and subtraction. So let's count it. Let me take different color pen for that. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9th. 1 second. Yeah, it's 9, 10th, and then come here. 10, 11, 12, 13, 14, 15, 16, 17, 18. So it means total 7 multiplication plus 18 addition and subtraction. Now, how many, if for any number of times, if we are doing addition of two numbers, then it will take O of n square time. So its recurrence equation is this is O of n square. Now, if we're going to solve this particular equation with master method, recurrence tree, iteration method, this particular will going to take O of this, means answer will come as n raised to the power 2.81. Now, from both previous approaches, we are getting O of NQ. But from this approach, we are getting n raised to the power 2.81. So it means Stressen's has reduced its time complexity. So This is the major advantage of using Stressen's matrix multiplication over divide and conquer technique and over normal multiplication. So this is the first example of divide and conquer approach. And now we're going to start with introduction to convex hull. So this question is also frequently asked in previous university question papers. But this will be coming as a theoretical question. Like for 2 marks, they can ask you what is convex hull. For 5 marks or for 10 marks, or means for 7 marks, they can ask you write a short note on convex hull. So for that particular question, first of all, you have to tell them like what is convex hull. So the definition is written over your screen. The convex hull of the polygon is the minimal convex set wrapping our polygon. It means, for example, if we have one input, as you can see here, if this is our input and in our input we have so many dots, as you can see here, there's so many points given in our plane. Now we have to find out the boundary that will going to cover all the points. So what you have to do means we have to find some boundary that will going to cover all the points, as you can see. So there should not be any point left out, means all the points should be covered. So you have to find out that you have to, the main thing is you have to find the boundary, means you have to find the wrapper for your points. Now how are we going to find it out, and why we are saying that convex hull is an example of divide and conquer approach? How you're going to apply divide and conquer strategy on this particular problem? Now, this is a very famous example that you can also use if this question will come in your exam. You can just take the help of this example in answering this question. Write a short note on convex hull. So, first of all, you have to write the definition, and after that, you can take help of some example that will help you to get good marks. So, if we have this particular question, and you have to apply divide and conquer approach on this particular plane. So first thing means if we just ignore this particular line for some time, just understand, for just remember that we have only one plane, and on this plane we have some points given. Right now, what we'll do, firstly, we have to find one x-axis. X-axis, likewise, if we'll take it like this, see, if we're going to take these points on some plane, and what we'll do, this is our x-axis, this is our x-axis, and this is our y-axis, right? So what we'll do, firstly, we're going to find 2 points. Points is A and B. Now, what this A denotes and what this B denotes. See, A is nothing. It's the minimum point, or you can say the minimum distance point from x-axis. And B is the point which is farthest from x-axis. So you can see here, if I'll talk about x-axis, so the first point that we are getting, if we'll start our journey from here, the first point that we are getting is this. This is our first point. And the last point, the farthest point, if we'll start our journey on the x-axis, is this point. So this is our A and this is our B. Now just connect these 2 points together. Just connect these 2 points together. Let me take eraser because I need to do some other things. So I'll rub this. I'll rub this also, and I'll rub this also. Yeah. Okay. So let me take my pen. Yeah. Now, after this, what the second step? See, the first step is you have to take two axes, y-axis and x-axis, and then after that, you have to decide your 2 points, that is A and B. A is the point that is very near to your x-axis, and B is the point that is very farthest from your x-axis. Now, after that, what you will do, from this particular axis, means from this particular axis, you have to find another point that is known as P max, or you can say D max. D max is from this axis the farthest point, or the point which is at greatest distance, is known as D max or P max, or you can the peak point from this particular axis. So clearly we can say this is the point which is at peak from this axis. The point which is at peak is this point. Now what you need to do, you need to connect this point with the end points of these axes. So just connect it. See, I have connected. One second. Just connect this. Yeah. After that, connect this peak point with the B. It should be straight line. So just take help of scale while you are doing. Now, Now I have, now we can see this line. One second, let me take eraser and I'll draw it neatly so that it will help you. Yeah. So we're going to connect these two lines properly. Will connect. It should be like this. Yeah, I have connected these two lines. But now what can I see? What s- I am just observing that this point is not in my polygon. This point is outside my space. So it means I need some wrapper so that this point can also come inside. So what I will do, I will take this particular axis as A, and this is my B. Now, for the second time when I will, so this is the time when divide and conquer will come into the picture. I will call this particular step, this particular algorithm again. Recursively, I will going to solve this problem again and again until and unless all the points will come inside one polygon. So if I'll take this, the farthest point will be P max. So the farthest point is only this. This will be our P max. And now what I will do, I will connect it with this and I will connect it with this. So now this is my boundary. This is my boundary. This is my final boundary. Yeah. So the same thing I have to do it here, but there is no point left out. So we'll not do that. Now again, we'll do the same step here also. So the farthest point which I can see is this, the P max. This is my P max. So what I will do, I will connect this with P max and I will also connect this with P max. Now what I can see, 2 points are outside. So again, I will take first this as A and I will take B and I will again call this function recursively, and this will be my P max now. And now I will connect this with P max and I will connect this with P max. Again, I will apply this on this particular area. Again, this will be my P max now. Now, one second. Now, this will be my P max and I will connect it with this and this. So this is my finest, or you can say the final polygon that I got, and this is known as convex hull. Now if I'll erase all unwanted edges, then the final thing that I will get is this. I can erase this, I can erase, and this I can erase. So this is the final convex hull that I got from my problem. And I have called divide and conquer, or I have used this divide and conquer approach for the 3 times. So this is the algorithm that we are basically using. And this you can also write in your answer if question will come for 10 or 7 marks. You can take help of this algorithm also along with the example. So this video also will also help you to get some presentation skills, or how you have to present your answer if this question will come in your exam. So the first step we are doing is, one second. So the first step we are doing is we'll solve the vector containing the points in the ascending order according to their x coordinates. And after that, we're going to divide the points in two halves, S1 and S2. And the set of points S1 contains the points to the left of the median, whereas S2 contains the points to right of the median. And last, we will going to find the convex hull for the set S1 and set S2 individually, assuming that the convex hull for S1 is C1 and for S2 is C2. Now we're going to merge C1 and C2 to get the overall convex hull, as we are doing here also. See, we are what we are doing. See, when we have done it for the very first time, so this point is left outside, so we have applied here. After that, we have applied same step here also, and here also, and here also. So we are adopting the same step, left, right, upper, down. We are doing it again and again. So this is known as divide and conquer approach. So these are the references. So thank you for patient listening. Do subscribe CETL channel and follow for more videos. Thank you so much.